In a loan database, there are 65 loans to clients with 5 years of business experience. Also, there are 93 loans made to clients with a college education. In the database, there are 111 loans to clients with 5 years of experience or who have a college education. The question is, how many loans were made to clients with a college education who also had 5 years of experience? We'll solve this problem using the Venn diagram given here, where set E contains the clients with 5 years of experience, and set C contains the clients with a college education. And therefore, the overlapping region, or the intersection of these two sets, would be where we would find the clients who have a college education and also have 5 years of experience. So our goal here is to determine the number of elements in the intersection of set E and set C. The number of elements in a set is also referred to as a cardinality of a set. So for our next step, let's list all the given information. We're first told 65 loans were made to clients with 5 years of experience, which means the cardinality of set E, or the number of elements in set E, is equal to 65. Two common ways to denote this would be to use vertical bars around set E for the cardinality of set E. Sometimes we'll also see it as n of E. This is equal to, again, 65 because set E contains 65 elements. Next, 93 loans are made to clients with a college education, which means the cardinality of set C, or the number of elements in set C, is equal to 93. And then finally, we're told 111 loans were made to clients with 5 years experience or who have a college education. The word or means union, and therefore the cardinality of E union C, or the number of elements in E union C, is equal to 111. And again, our goal here is to determine the cardinality of E intersect C, or the number of elements in E intersect C. So to answer this question, we'll be using the cardinality formula given here below, where the number of elements in A intersect B is equal to the number of elements in A plus the number of elements in B minus the number of elements in A union B. Before we apply this, though, let's make sure we understand why this makes sense. Again, our goal is to determine the number of elements in E intersect C. Our formula tells us to first determine the number of elements in set E, our first set, and then add the number of elements in the second set C. Notice when we do this, though, we count the number of elements in the intersection twice. So right now the elements in this region here have been counted twice, but then we subtract the number of elements in E union C. When we subtract the number of elements in this union, we subtract the number of elements that are only in E, only in C, and also in the intersection of E and C. So when we subtract the number of elements in the union, we are left with just the number of elements in the intersection of E and C. So again, applying our formula here, this is going to be equal to the number of elements in E plus the number of elements in C minus the number of elements in E union C. And notice how we have all the information we need from the given information. This is equal to 65, the number of elements in E, plus the number of elements in C, which we know is 93, and then minus the number of elements in the union of the two sets, which we know is 111. So this gives us 65 plus 93, which is equal to 158, minus 111, which equals 47. So there are 47 elements in the intersection of set E and C, which means 47 of the clients have a college education and 5 years of experience. So let's go ahead and write that out. 47 clients have a college education and 5 years of experience. So while we are done with this question, let's look at this Venn diagram again. Notice how we know the number of elements in set E, the set here, is 65, where 47 of the 65 are also in C, and 65 minus 47 is equal to 18. So there would be 18 elements that are only in C. Notice how here we do have 65 elements in set E, where 18 are only in E, and 47 of them are also in C. Next, we also know there are 93 elements in set C, the set here. 47 of those 93 are also in E. 93 minus 47 is equal to 46. So there are 46 elements that are only in C. Again, notice how set C does contain 93 elements, where 47 of them are also in E, and 46 are only in C. So this connection will be very helpful in the next several problems. Thank you for watching.